Today I want to show you this robot game and some of my project. In this Python project, a robot has to go on a clockwise direction through all the circuits, take all the objects, and also decide in which direction to turn. The challenge has been to not hardcode how to turn and how to detect the object in a correct range of distances. Here I improved a lot of my software skills and was one of my first projects using Python. The second robot game is Level Up. It's always a robot moving on a circuit, but this time using the ROS Robotics framework. The user is allowed to interact with the robot through a terminal. And so I created a custom node and a topic where published velocities. Such velocities have a coefficient, and whenever the user will press the up arrow or the down arrow, this coefficient change, multiplying the current velocities and allowing the robot in the visualization to change speed. The third project is a level up of the second. I used Airbits and gazebo visualization for moving the robot on a 3D environment. Has laser scanner and is able to scan the environment around it, detect the obstacles. The user can move the robot on three modalities: self-assistant, manual assistant, and autonomous navigation by giving the coordinates of the destination. The third project has been Cyborg Hands. I bought a toy and I measured all the components and made a 3D model using Creo on top of them, assembling them. Our project is about computer vision. Really light and is really used on robotics, detect and infer information from the video cameras. Here you can see my arm moving a glass of water, and the arrows in green are magnitude and orientation of speed vectors. Before I used Lucas Canad, but now I use Bach. Is slightly slower in a computational point of view, but it's dense and gives a lot of information. In this color map you can see the red region where the velocity is higher. The fourth project is about machine learning. I had to reduce the dimensionality of the input for predicting velocity in the output. Here you can see me recording the camera where I collecting the frames, but collecting also orientation and velocity of the pendulum. This allows me to create another Python script that is able to bind such informations and create a custom dataset to train my model, present the results in the interviews. My first internship has been done in ABB in the robotics department in compile manipulator team, working on a new generation of robots. My task has been to create an interface for interacting with the robot. In particular, from the desktop application, you can decide the target position and the robot will reach that position, but not only, will also align to the orientation described in the interface. This is the future, and this is how manipulation and mobile platform in the current state of the art look like. After ABB, I have been hired by another company. My job was to create applications. Most of the time I create machine learning applications because are in demand in the industry. Here in particular, I wanted to take off the screws and put them aligned on a metal panel full of holes. I struggled because the gripper wasn't able to take the screw always on the same pose, and this, by taking it wrong every time, struggles to align correctly to the hole. As you can see, the screw keeps moving and the robot doesn't take it always on the same way. Even if I create this meta structure for making it easier. Here you can see the final result. Speeding up the video takes the screw and then needs space for lines. I prevented the collision because, as you can see, it's not aligned correctly and perfectly to the hole. Be curious, learn always from state-of-the-art robotics nowadays. SoftBanks did great projects. Now you can see the dexterity of this robot while dancing. But not only, Pepper Robot is an incredible social robot, able to interact with people, with children. I created many applications, many robots in museums. I want to thank you very much for your attention. Please subscribe and put a like if you want to see more.